There's a new node under each database in the Object Explorer, which is columns, which you can then pretty instantly see how useful that could be. So that's going to list all the columns across that entire database. Previously you could only see columns within one table, so uses might be you might want to find out how many tables contain a particular column name as another quick way of doing dependency analysis. So here at a glance we can see that we've got the customer table has that as a serial column, whereas it exists as int on those three other tables, all of which in fact have foreign keys back to customer. You can see that in the icon showing foreign key and primary key. You might want to see what tables contain a particular data type. Yep, so for example we've only got one table that relates to time series that contains a big serial. Can be extremely useful prior to doing a schema change to find out where all occurrences of a particular thing are located, to make sure you pick them all up. You have search facilities in here, so I could do it that way. So it filters the outputs based on column, table, data type. So that's another way of finding all the objects of, say, big serial. Well, let's generalize it slightly, let's say serial. We can see both big serial and serial. Next, going to look at mapped users, which is really quite interesting. So mapped users were introduced in IDS 11 so that you can define usernames and passwords with which you can connect to Informix that don't actually exist on the host server. That can be very useful for systems where the host servers don't actually really need to have separate user accounts. You want to maintain those users entirely in SQL. Those user accounts are not used for any kind of command line access. Why it's called map user, I'm just going to bring up that dialog. So you get that under Tools, Security Manager, Manage Mapped Users. So the point of a mapped user is that if you're going to give access to a user, then should it need to do a call to the operating system, it has to have a substitute user nominated with which it can run that command. So the only way that you can create mapped users is you do need to say what the surrogate username is should it need it. Okay, so before you can do that, there are some prerequisites which I've just sorted on this server. All of this obviously is in the IBM Info Center for IDS. A file must exist called allowed.surrogates. It is in etc Informix. It's not in $informix.dir/etc. It's in etc Informix. The file allowed.surrogates must exist in there with ownership of root and not writable by other users. The preferred group is Informix. That must contain the list of usernames and user groups, which are allowed to act as surrogates. In that file, user is then followed by a comma-separated list of allowed usernames, group, comma-separated value of group names. If you use users or groups, you have to provide the integer IDs. Clearly, I think names are easier. You need to declare user mapping enabled. You'll see in a moment that we can change the mode of user mapping within Server Studio, but that has to be declared first, so that you can then get it to recache the surrogates file with that onMode command. Once you're set there, in this dialog you can add or edit users. It's exactly the same obviously with edits, it just comes up with pre-existing details. Normally you would just give it the mapped username so that you'll be able to connect to Informix as user ghost, and then the surrogate username. The rest you'd normally leave blank, so we're providing that by name and not number. We're going to let the group be assumed to be the same as operating system user Tom. We're going to assume the home directory is the same as operating user Tom. I think normally you would not be allowing any of those system privileges to a mapped user, but you have the ability if you need to. So whether or not user mapping is on, and whether you're going to allow any of those admin privileges is controlled here. Normally you'd leave that as basic. There is a limitation in this version that's going to be fixed shortly, that the other thing you need to specify in there is the password for that mapped user. So I'm sure by the time you come to try this, that will have been applied in the next patch. So if you want to test this, so if I run, that would set the password in SQL. That's the fix for the moment, having created a mapped user. I'm then creating a procedure which I can run as that mapped user to prove how it does behave if it needs to do something in the operating system. So here I've said just run the date command redirected to file junk. If I then connect to, I've created an alternate data source here that connects as that mapped user. That was easy to do because in Server Studio, if we edit a connection, we can do save as to clone it, and then I just change the username. So if I now run that connected as user Tom, it will create the junk file in Tom's home directory owned by Tom. So that's connecting as user ghost. It will run the operating system function as user Tom. Configuration of automatic storage allocation is now provided. So in the Object Explorer within an instance, go into storage and then storage pool, which then shows these properties. So this collection of items under automatic expansion configuration is whether existing chunks can expand themselves, and these parameters, that's just those DB spaces chunks that you have stated should be expandable. Here we're saying that nothing will happen until there's only 1000k left. You might want to have a wait time before doing anything. For example, let's say there's a process which might create a large temp table. If it were to do it in the wrong DB space, it would hit the end stop, it would crash the application, that temp table will automatically get removed straight away as soon as the session ends. You wouldn't actually want to have that DB space automatically extended as soon as it filled. So we've got a wait time in there of 60 seconds, so that only if 60 seconds later is it still full would it then automatically extend the size of that chunk. Yeah, by default much of that will be disabled. Having enabled them, you would find that the configuration parameters changed would be those. So that's the mapping of those screen fields to onConfig file parameters. Conversely, if you've got a storage pool set up, so instead of extending existing chunks, if you want it to allocate another chunk to the DB space from a pool, these are maintained in the bottom segment of that screen. So here we've got an existing pool entry currently not allocated. I'm just going to demonstrate creating a second one. I'm going to create a second one like that first one. So the path that I give it, that has to exist. It has to be fully writable by user and group informix and not by anybody else. It can't be readable even by anybody else. So it's chmod 664. I've given it this is just a test instance, I don't want it to be too big, so I've given it a chunk size of 50,000k, and I've said that that itself would be extendable. You can, if you wish, you can, in fact I'm going to reduce that to, I'm going to declare that in exact meg. We could have that extendable. If you didn't want it to be extendable, then we could say it can get no bigger than that. If you were providing additional chunks in a pool rather than extendable chunks, it would kind of be a bit irrational to have the pool chunks extendable. So if you are creating these, I guess it's more likely you'd have them in a fixed size. That error you can see there was indeed because I forgot to set the permissions to 660. So going back to what I was saying, we're going to do that as the fixed size. We can see the difference between having that pull chunk as being extendable or fixed size.